Hello everyone, I hope you're all doing well. So, today we are here to continue what we started the previous class about sets. Alright, before we go to today's topic, let me quickly brush through what we did the other time. Alright, so the other time, define what a set is, and then we came in conclusion that even sets started were then from creation. Okay, when God himself was creating things, he mentioned them group by group, and that group is a set, right? Okay, so we came to talk about notation of a set. What when something is written on the board, we can identify that it's a set. So the notation of a set, we came to conclusion that a set should is usually denoted by capital letters such as A, B, P, C, Q, X, and Y, and we say that always when a set is written, it has braces. And so today's topic, we will go to how to describe a set. We will do exercises, alright? Alright? But before we go, as I always tell you, do not forget to donate. Your donation counts. Your donation is helping us to do more works and to do accurate jobs for you. We encourage you to donate, whether day donation, weekly donation, monthly donation, 2 weeks donation. And we are so happy that you will receive your money, and then and then we will say thank you to you. And please, 0245215266, 0278887080, these are the numbers you can donate through. You can follow, alright, the platform to do your donation. So today we are looking at ways of describing a set. Okay, so how do we describe a set? A set may be described by 1. Okay, let's see. 1, listing its members. Okay, and what does it mean? I think this is very clear, right? Let's say example, we can say that P equals, you know how to write sets. Bring in your braces. It says 2, 3, 4, 5, 6, 7, and then you can end it there. Or we can also say that P, let's use Q. Let's use Q into brackets, the list of 2, 5, 3, 5, 7, 9, or let's say 11. I just want us to use a different letter. Okay, so let's say A equals, it says that set of set of month. Okay, so it says a lot. Let's end it there. Okay, alright, so the first one that we were talking about is that a set can be described by writing its members. Alright, let's go to the second part. Okay, giving a word description of its members, of defining the properties of the set. This is also very simple, right? Okay, so don't be scared. Okay, until I see any beba and tobo I see it. So what we are saying is yeah, but describe sets. Okay, and the description of sets, we have 1, 2, and 3. Okay, but say yeah bobo so bank kakra. Okay, nti yes first one no or describe a set first the decline no. Okay, it can be say you be listing members no. Okay, you're listing members, maybe a set of maybe your class. Okay, so your class, then we mention the names, those in your class names. Okay, so you can say Otis, Ajay, Owusu, Trematin, Junior. It means that you are listing the members. Nti wo bobo omudin. Ana the etosu mienu no. Yebetimi a describe it, the set no with a word description. Okay, yebetimi the some words be a word be a gyina ho. Okay? Amano. Okay? So let's see example. So giving a word description of its members or defining a property of a set. Okay, so let's see example. Maybe if the example comes, you understanding. For example, the sets P and Q, all right, with this 2, 3, 4, 5, 6, 7. Instead of rewriting 2, 3, 4, 5, 6, 7, we can use a property to describe it. Okay. January, February, March, April, May, June. We can use a description for it. Okay. So now let's do this description. Okay. So this description, what do you think will be the description of 2, 3, 4, 5? Okay, let me bring one here. So let's look at set P. Okay, at example 1. All right. Okay, so let me write them. Okay, so P equals, okay, let's write it. 1, 2, 3, 4, 5, 6. All right. Okay, continue. All right, instead of rewriting it this way, we can say that we can come and write it in this way, describing it. Okay, making a description for it. Okay, so we do it this way. P equals, so what do you see? 1, 2, 3, 4, 5, 6. So we can say P equals the counting numbers, right? Or we can say positive integers, right? Or we can say P equal a set of whole numbers. They are all correct because 1, 2, 3, 4, 5, 6. So let's do it. So we say that P, okay, could be said that is positive. Okay, positive integers. You can also choose to be whole numbers. P is a set of whole numbers. You can also say P is a set of natural numbers. Okay, so now let's write the Q again. Let's rewrite the Q here and then try to bring a description for Q. Okay, let's try to do it and let's see our results. Okay, so 2, 3, 5, 7, 11. Okay, so what comes in your mind? So write the description down. Okay, Just describe this set Q. Write the description down. I'm giving you 1 minute. As you are writing it down, just remember that your donation counts. Okay, so do your donation from your heart, whether weekly, could be 5 cedis, could be 10 cedis, could be 15 cedis, or it could be 2 billion Ghana cedis, it could be 100 cedis. It will be answered. Catch your mommy, I'm donating, right? Catch your mommy or papa, now, Obia or show. No donate. Okay, so now let's get back to business. All right, so now we are using a word to describe kill. Okay, so what did you write? You've written something, eh? Good. I think it's correct. What you wrote. All right, so this is mine. Like I see it, 2, 3, 5, 7, 11. Yes, it's a whole numbers. True. But it follows a trend, right? A sequence. 2, 3, 5, 7, 11. So I can detect that this could be a prime numbers less than 12. Okay? A prime numbers less than 12. So let's see. Let me do my own. Prime numbers less than 12. Okay? Less than 12, because the prime numbers, we all know the prime numbers. Okay, we are going to look at those things. Okay, prime numbers, odd numbers, even numbers. We will go there very soon. Okay, so that it won't confuse you. So you will come and understand what an odd number is, an even number is, a prime number is, prime factors. Today we have a lot to talk about. Okay, so sometimes our time is the problem. Okay, so we are going to make sure that all right, so more time. Okay, so all right, so we've been able to describe Q. So let's describe A. I think the A, it has come into your mind, right? So there's no need for us to do it. So let's go to number 3. So we've seen something. We're describing a set. We've said that a set could be described by listing its members. That's the raw one. We can also come in without listing the members, but we can use a description or define a property for it. Okay, so a set of shoes. We go to the third one. All right. Okay. So let's look at the third one. The third one, we say that we can use a set builder notation. What do you mean by using a set builder notation to describe a set? All right. So now let's see. But before then, let's look at the PQ. Alright, the set P, set Q. Alright, instead of for us to write it maybe P. Okay, now let's list the P so that you understand it. Okay, the person will tell us here. So the P, okay, the P that we wrote, the set P that we are using. So the P, 1, 2, 3, 4, 5, 6. Okay, then we bring our dots, meaning that it continues. All right, so this is how we do it. We could use a positive wider view. We could use positive integers. But here's the case that we want the range. Okay, so from 1 is a positive integer ranking from 1 greater than 6. Okay, so we can write it in this way, that x, which the x stand for the list. X is set that, okay, X is said that 1 is less than the members, which is the X, greater than 6. Okay, so this means that when we are listing this mathematical expression, under set builder notation, we know that the X, which is the number, okay, which stands for the group, the set, the members in the set, is said that the X is the member, right? So X, which is the member, is said that P equals X is said that 1 less or equal to X, which is the member, greater than 6. So it means that when we are listing the numbers, 1 is included. Okay, 1 is included. So that's how we write it. Okay, here we go. So is it clear now? Okay, so now let's set another example. Use the Q, the set Q. Okay, so we are looking at set Q, which its members 2, 3, 5, 7, 11, right? Okay, so pen it down. So use set builder notation to write Q. I'm giving you 2 minutes. No, 2 minutes is too much. I'm giving you only 5 minutes. 5 seconds to do that. Okay. So while you are doing do not forget to do it. Okay. Now let's look at the range. Right. So we see that the Q has 2, and it has the ending has 11. This one wasn't having an end. Okay, it's to infinity, so you say greater than 6, but here it has an end, which is 11. All right, and it has 2. So how do you write this? It says that Q equals, set the X to be the members. Okay, so X is said that 1, okay, 1, there's no 1 here, so 1 should be less, right? So 1 is less than X, so we have 11 at the end. So we say that less than 1 less than X less or equals 12. Okay, oh sorry, no, it's not less or equal 12 because we don't have 12 here. Okay, so it's less than 12. We can bring less or equals 11. That means that the 11 is part. Okay, so let's see, less or equal 11. Okay, we say that X is said that its member is said that X is less than 1. Okay, so we start from 2 is less than 1, so we start from 2 to its members less or equal to 11, meaning that 11 is part of our counting. I hope it's clear. Let's look at another example. Let's say here we are looking at A, set of A equals, let's list it this way, 1, 2, 3, 4, 5, maybe 10. All right, so let's write it this way. Okay, so now let's look at this. How do we write it? Put it down. Let's see. Okay, just look at it and let's see what's up. Okay, all right. Alright, so you've done something. Na me kai will say a donation who here pa, so donate with the given numbers. If you have any concern to, just send us mail, or our WhatsApp platform is there. Just click on it, the platform, and then click on the WhatsApp and start giving us message. That's all. Alright, so you've written something, eh? So let's look at this. Alright, so here we go. I know you'll get it correct, so let's see. So here we go. Let's pick out our pen. Okay, so we see the A. So we say that A, set A has members, which the members is X, right? Oh, X is said that. Okay, let's look at this. 1 is part, right? So 1. So if it's part, what do? We bring less or equal to, right? So just because 1 is part, so if we say it's less than 1, it means that 1 shouldn't be part. It means it should start from 2, because any number that is less than 1 should not be part. So here we say that our 1 is part, right? So our 1 is part. Okay, so if it's part, we say that less or equal to 1. So any number less or equal to 1 is part of X, which is the member of the set. Then we come here and we say that less or equal to what? 10. I hope it's clear. I hope it's very clear. Okay, I hope it's very clear. And that is it. Okay, so that is how we describe sets. We are good to go. Okay, and the young family tree not here. So what's a set we have? 2, 3, 5, 7, 11. Okay, so say your trouble be say it means say number 1 no members are a work queue no members are work queue no ye di gina homa X no. So X is said that the members is said that members ne wo no actually say X no the members ni say bibi ye less than 1 no enya ne member enti, but bibia aye ne less than aye equal to, so aye 11, that is the end no aye ne member enti all list here something less than 1 enya part, no mom greater than 1 no aye part, and you can bring it 1.1, 1.2, but if you see the sets here, it's 2, 3, 4, 5, 6. Sorry, 7, 11. So with the 11, no, number be even 10.9999999 recurring, less than 11. The bit me the aba, not 11 number nankasaba. It say na confused no. Yes, I set here another example with the same 1, 2, 3, 4, 5, 10. Say no 1 can ho. It anything be greater or equal, less or equal to 1 no is part of X member. It will stay X member, and so if you will be say no be who say there a less than 10 equal to 10 no. And the 10 no is part. But every number be a less than 10 be say the greater than ever share ha. It means from 11, 12, 13, but when it was set able. Okay, so I hope it's clear. We thank God that you understand. All right, so we move on. So that is how we describe sets. So describing a set, we have 3 types. Okay, we have three types. Okay, so we have, one, listing its members, and then two, we can use, a description or a property to define the set. Okay, to describe the set. And then we say that we can use set builder notation. Okay, so this one's set builder notation when you go to your graph aspect, especially if you are listing the members of the members or the numbers to use at a given range for your graphs. Kofo bebree mistake if you see less or equal, greater or equal. Okay, if the members are less than 1, and how share asem plotty minus 0 minus 1 is less than 1, so the element should be from 2 to 11. Okay, so we will come there. Now we know all these things. Let us look at the definitions of some elements that we are going to use. So today we are looking at ways of describing a set, and we are done with that. So let's look at some definitions of set of numbers. Okay, so let's make the topic as set of numbers. Say that sets of numbers. Alright, so now let's look at set of numbers. The set of natural numbers. That's right. The set of natural numbers is denoted by the symbol n. The symbol n. Okay, so when there's a list, and we do we use n to it, then it means that it's natural numbers, and we can list example of natural numbers. So what comes in your mind? What? Can we list it? Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's make it 10, 11, 12, 13, 14. Total is the natural. Okay, so they are whole numbers, infinity. Okay, so now let's look at the B. Okay, we say that the set of the whole numbers. So a whole numbers. Okay, so set of whole numbers. The set of the whole numbers are a set of the whole numbers is denoted by the symbol W. So let's example of the whole number. Can we mention them? Example. Okay. Can we mention them? Do you know that 0 is a whole number? We can talk about 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what's the difference between Write it down. What is the difference between a natural number and a whole number? Let's write it down. Have you seen the difference? A whole number and a natural number. What is the difference? Okay. That's correct, you see. So the difference is that when we are listing a whole numbers, we can have 0 as a whole number till the infinity. But when we are looking at natural number, it starts from 1. That's the only difference, right? So now let's go to odd numbers. An odd number is a number which, when divided by 2 leaves a remainder of 1. Okay, so that is odd number. So any number that when we divide it by 2, we get, what do you call it? We get a remainder. 1 is an odd number of odd number. So any number divided by 2 gets you a remainder. Examples. Okay, so list them. Can you list them? Yes. Alright, so we can list them. We can have minus 15, minus 13, minus any number, but let us use from minus 6, okay, so that it will be simple. Minus 6. Oh, sorry, let's use minus 5, minus, can we look at minus 3, minus 1, right? Minus 1. Can we look at 1? Can we look at, can we say 3? Can we say 5? Can we say 7? Can we say 8, 9? Can we say 10, 11? Can we say 12, 13, 14, 15? We can mention and mention and mention and mention and mention, because they all can be divided by 2 with remainder 1. So any number divided by 2 remaining a remainder of 1 is odd number. Let's go to even numbers. Okay, what we're doing will help us understand. Okay, let's say an even number. Okay, an even number is a number which, when okay, divided by 2 leaves no remainder. So that is an even number. All right, so can we set an example? Of course we can. All right, so let's look at examples of such a set. Example, we could talk about numbers divided by 2 with no remainder. Come on, let's list them. Come on, list them. Let's list them. We have, let's start with a negative. We can start with negative 1 trillion, but we want to use negative 6 first. Negative 6 comes to -4, we come to -2, we come to 0. Are you okay? Alright, so we go to 2, we go to 4, we go to 6, we could go to 8. You can mention and mention and mention, okay? Divided by 2 with no remainder. So if 0 divided by 2 is 0, so there is no remainder. That's why we brought 0 to it. Okay, alright. So after the odd numbers, let's go to this. Okay, we are going to factors. Okay, an integer x is said to be a factor of another integer y if x can divide y without leaving any remainder. Example, set factors of 48. Let's go. Factors. Okay. E. Okay. So the E, we talk about factors. So what are factors? We say that okay, let's see, an integer okay, an integer x, is said to be a factor of another integer y, okay, if x can be, or x can, okay, if x can divide y, okay, if x can divide y without leaving any remainder, right? So I hope it's clear. We can have a number x when that number x, we look at other integers that can be divided by the x with no remainder. Therefore, we can say the thing, those numbers are factors. An example, let's look at this example. Factors of, let's say, 48 will be equal to what? Can you list them? So from 1, when 1 is divided by 48, we get 48. So there won't be a remainder. Okay, so we get 48. But when we take off 3 dividing 48, there will be a remainder. So 3 can never be the set. Okay, there can never be factors of 48. So what about 2? Yes, when 2 is divided by 48, you will get maybe let's see, we will get 24, right? So it's a factor, no remainder. What of 4. Yes, 4 can be, we can divide 48 by 4 with no remainder. But what about 5? There will be a remainder, because 5, 9, 5, 8, 40, 5, 9, 45. There's a remainder of 3, so it can never be factor. I hope you are getting it. So now let's go to 6. Okay, so 6, when 6 is divided by 48, it's clear. Okay, it's clear that there will be no remainder. Okay, so we take off 6. What about 9? Sorry, 7. 7 can't be, because when 7 is divided by 48, there will be a remainder, so it's not a factor. What about 8? Sorry, what about 8? Yes, 8 cool. It's a factor, because when you divide 48 by 8, there won't be a remainder. So now you understand what we are doing. Okay, into number BR would be divided the number now you have the factors now. Remember BN catching, then we can say that it's a factor of that number. You get it? So let's write 24 as then we write the 48 itself, because when 48 is divided by 48, we won't get any remainder. Or let's look at a prime factor. Okay, set of prime factor. Okay, so we can say set of prime factors. Alright, so like I always say, you gotta donate for us. Okay, and try to donate. You yourself can put, can just make a susu box, put one CD. At the end of the week, you give to us donation. You can put it for 2 weeks. You can put it for monthly basis, and anytime, any day that you want to donate, just donate what you have from your heart. Alright, so now let's look at prime factors. Okay, what is a prime factor? So we talk of it to be, it's a set whose members are prime numbers. Okay, its members are prime numbers, so that's a prime factor. So when we talk of factors, alright, factors, so when we talk of factors, we say that factors are that set of a number of that integer that can be, when divided by the integer, remains no remainder. Okay, and now we are looking about prime factors. So prime factors is said that integer that we are finding out, okay, if that integer, its members are prime numbers, then it's a prime factor. Okay, into fancy 48, you divide it by 1, 2, 3, 4, no remainder. Okay, but you bet me prime factors out of the 48. You bet me it could be 1, right? Yes, we can list of 1. Okay, it's say you the set of that factors of 48 now maybe 47, now 45, and we are, then whatever is in a prime number br, we take it as prime factor. And that prime factor, the factor is the members from the 48 or from that number. I think say mudaho. Okay, so let's set an example. Factors of 38. Let's look at factors so that you get it. Okay, factors of 36. Okay, let's look at factors of 36. Okay, so now let's look at factors of 36. So let's make it equals. Okay, we can talk about 1 is a factor of 36. We can talk about 2 is a factor of 36. Can we talk about 3? Yes, of course. 3 is a factor of 36. Do we have 4? No. 4 divided by 36, we won't get it. Okay, now let's talk about 4 here. 4 1 4 1 2 32. 4 9. 4 times 9. 4 9 36. Yes, so we can talk about 4, right? 4 9 36. 4 10 40. Okay, so can we talk about, if we talk about 4, then we can talk about the 9 too. 6 36, so we can talk about 6. Okay, there's no 8. Okay, you say that factors, numbers that when we divide by the 36, that we will never get a remainder. So let's see 8. No, there will be a remainder. We talk of 9. Let's talk about 9. Yes, 9 is 4. So let's talk about 10 cannot. 11 cannot. Okay, 12. Yes, 12 can. Because yes, 12 can. Alright, so this is 12. Now we want to know the prime factors of the factors that we find from the factors that we have been able to list them. So what are the prime factors, the prime numbers in what we've listed? So so before then we need to go and know what is a prime number, right? You get it? Okay, so if you don't know what a prime number is, I'm sorry, we can't do this week. Okay, so before we do that, let's take a look at prime numbers. Okay, then we come and list what we have. Okay, then we talk of multiple numbers, then we end the class. All right, so prime number is any positive number that is exactly divisible only by itself and 1. By itself and 1. Okay, so any number that can divide it by itself and 1 is said to be a prime number. Okay, all right, so if the number will be divided by itself, so if you have a number that can divide by itself and only 1, then we can say that is a prime number. All right, so a prime number is any positive number that is exactly divisible only by itself. Okay, only by itself. Okay, so we have a set of prime numbers or factors is a set whose members are prime numbers. That is, each number has no other factors except itself and 1. Okay, So let me write this to it so that the explanation will come very well. So we say that each okay, each members has no factors, no other factors except itself, and 1. Okay, I think it's clear. Alright, so numbers that it can be divided by its own self. Okay, alright, that's it. It's a prime number. Okay, or numbers that has no other factors except itself and 1. Alright, so if you take 1, 1 has a factor of 1, but when you take off a number like 4, it has factors. Okay, so if any number that can only be divided by itself, okay, so only it divided by itself with no remainder. So if you have any number that has factors, then it's not a prime number. Okay, so when we talk of less prime numbers, okay, a number like 1, 2, it can be divided by itself. Alright, when we talk of 3, has no factors. 3 is 3. Okay, you just can divide itself and give 1. So let's take example, and then we come to our work, our set of prime factors. We come to our work that we wanted to do. Alright, so example, we have set of 2. We can talk of 3, and it has no factors. We have of 7. We have of 5, and has no factors. We can talk of 7. It's also part. We talk of 7. We have, it has no factors also. Why don't you go and bring 15? Like 15 has factors. You get it. But when you talk of 17, it's a prime number. Okay, alright, so 7, we have 8, 9. 9 is not a prime number because 9 has factors, which is 1. It has a factor of 3. You get it? So we can use 9 as a prime number. When we talk of 11, yes, 11 is part. We talk of 10, it can't be because it has factors. Okay, so it can't be possible. When we talk of 13, okay, 13, we can talk of 15. No, we talk of 40. 40 has it. 15, 16. Can we talk of 16? 16 has it. 4 times 4 is 16. Has no way. So we can talk of 17. 18, 19. We can talk of 19. You get it? So we can set a whole lot of example prime numbers. Okay, so these are prime numbers that we've listed. We have a lot. Okay, so anytime that you say list prime numbers, toboase, relax it, green, kakra, kwechi. We say number over arbitrary or factors are now numbers be betimi divided with no remainder. Okay, so this thing, no, you can list numbers are first of all, no, mature formula, no, you can just list if you say amount list prime numbers of 50. Hey, how could you get prime numbers of 50? Less numbers divided by 2 will give you remainder 1. We are still we are now about now. If you was be taking another property, we will say number way our factors. Number way our factors nature say number ne betimi divided by a certain number. A certain number, a number be betimi divided by that number no. Remainder beyond battery. So remainder battery pair. That is we need factors. Remember battery and battery pair. Just say number near correct. It could be said as prime numbers. Okay. Alright, so that is it. So now let's come back to our work. Say we want to find prime factors FG. Okay, so we need to find our prime factors here. So let's talk about prime factors. Prime factors, okay, implies equals, so factors of 36, which is 1 2 3 4 6 9 12. So we want the prime factors, and we know that prime factors are numbers that has no factors. Okay, so we can talk of 2. Can we talk of 3? Yes. Can we talk of 4? No, 4 has, we can't talk of 4. Can we talk of 6? No, 6 has, factors. Can we talk of 9? 9 has factors. 12 has factors. So we can talk about 2 and 3, because 2 has no factors. And divide it safe. Alright, and we have the 3. So that is it. Okay, so quickly let me brush through multiple of numbers. Okay, multiple of numbers. Alright, so now let's look at that one and then we end the class. Okay, so multiple numbers. You say that the multiple number of a number, let's say number x, okay, refers to any number formed when that number, which is x, is multiplied and is multiplied by any integer, right? Okay, so we talk of example. Let's talk about the example, and then so when we talk of multiple of 3 equals, just think about multiple of 3. So 3 1 3 1 3 3 3 3 2 6 3 3 9 3 4 12 3 5 15 3 6 18. Alright, 18 3 7 21 3 12. That's the multiple. Charlie, let's end it here, okay, because we've done a lot. Alright, so today's lesson, let us wrap up and then continue next time. We talk about ways of describing a set. You know that there are 3 ways of describing a set. We can list the numbers, we can make a description with a property, and then we use set builder notation. And the next time we come, we will go to the set builder notation and then you are going to apply, the definitions that we've looked at, set of numbers definitions, to look at what we wanted to look at. So we use set builder notation to list prime numbers, odd numbers, even numbers. Then we do the ranging, as we did it here. You look at it. Alright, so we end it here. We advise you to keep donating to support us. 0245215266, 0278887080. You can follow to proceed on the platform. Just click on the lines and then do your donation. You can also download ebooks for only 10 Ghana cedis, just to show appreciation and our work that we're doing. We're doing a great job. We have ICT, we have Tree Akenkan. If you want to learn Tree, how to read Tree, if your mom wants to know how to read Tree, just tell your mom, your father to go and learn how to read Tree, and then you can read the scriptures to understand it. All right, it's important to understand scriptures so that you can identify false religions that they are disturbing us, so that we can be very close to our God in heaven, whose name is Jehovah. And that is very important. Okay, you can also join our ICT class, and don't forget to donate. Okay, donate what you have. Okay, do not donate what you can afford. And then remember to make another. If you want books, if you want pads, if you want any kind of go to our stores and do what you have to do. So next time we come, we are going to look at the set builder notation, writing, using how to use it to write, to list all what we've discussed. Then from there we will go to sets, using Venn diagrams. Then we proceed. Okay, like I told you earlier on, that this set is everywhere. So elective maths and the core maths and the JHS for SHS2. Alright, that set is set, so you can find it there, and then enjoy. Okay, but the SHS and the JHS, I think we are starting with real numbers, and then we are good to go. So please don't forget to tell a friend, for a friend to tell a friend, and a friend to tell a brother that yes, you are benefiting from ftpclasses.com. Introduce to your friend, and God will bless you. Have a nice day. We are waiting for your donation. Do it right now. Bye bye.